Okay, we're talking about inverse functions today. Algebraically, graphically, and numerically, we're going to hit that again. The first thing I want to go over is what does that look like algebraically? Well, I could say the same thing about you, but do you remember the process? And if not, okay, so if it says f or g or h of x, set it equal to y first. Okay, next. I hated this last year, yes, me too. Okay, now we have to solve for y. So yeah. Okay, so then you write it as f inverse, but only if it's a function. Okay, there are inverses you will run into that are not functions. Lots of them, actually. Let me show you one. Okay, so I'm going to show you okay, so I made a statement. Okay, f is x squared on this graph, right? Graphically, if I do the inverse, so f is a function because it passes the vertical line test, yeah? Here is the inverse. Is it a function? No. Okay, so be careful when you calculate an inverse. Let me show you the one we just did. We did 3x plus 2.
Yes. 3x minus 2. Oh, yeah. Minus 51.
3x and then minus 2. Okay, so there is 3x minus 2. Algebraically, we got 1/3 x plus 2/3. Graphically, we are reflecting f over the line y equals x. Okay, so any point P is going to be the mirror image, so it should hit somewhere over here, right? You're reflecting P over this line. Look at that. Okay, so I've just mirror imaged P. What if I choose a different? Okay, so as you can tell, this is tracing the line of the inverse. The inverse looks like that. We can see that the y-intercept is 2/3, and the slope is 1/3. Up 1 over 3. Okay, so graphically, if you reflect f over the line y equals x, you get the inverse. You can do that algebraically and graph them both, or you can just know how to do it graphically. How many of you are geometry people that are very visual? Like, if I told you to envision a solid, cube, would you be able to visualize it?
Yeah.
Okay. Then I said, what if you expanded the sides by a factor of 2? You can stretch it in your mind. You're just kind of visualizing it. People that are very visual could take that line and reflect it over in their mind without drawing it on paper, and then put it on paper without an algebraic equation. That's the kind of student I am. I can manipulate things in my head. Pictures.
There's people who do that for kids.
Okay, I'm not quite that skilled. Let's try a different one. Give me a
4. Big 4.
about something a little bit more messy. My night, you dream about this at night? Right there, yeah? First step, set it equal to y. Now we got to swap them. Now, if you know how to do this, have at it. If you don't, okay, so we've swapped. Now we got to solve. All right. First, all right. Next. Yep.
Wouldn't you cross over the 1 first?
No.
Get rid of the exponent.
This is grouped. You cannot add 1 out of there because it's cubed and grouped with the y. So you have to remove, okay, you have to remove that. It's like it's protective armor. You have to remove the cubic before you can get to the heart of the matter, the minus 1. Okay? So you have to remove the outer shell first. It's like an onion. There you go. Now you can do the one. Why did I what?
Wait, I'm confused on why when you rewrote it when it's equals 1 minus 1 minus 1 plus.
Here?
Yeah.
Because I didn't change the y and minus 1.
Oh.
All I did was the cubic.
Oh, thanks.
So you just rewrite it if you didn't change it. Is this a function?
So it's not. Do you read it y or do you put back to x?
Okay, we're going to leave it. If it's not a function, we have to leave it y equals. But if it is, we're going to rewrite it g inverse.
Well, wouldn't it be so much of a function?
Okay, here, let me picture it for you.
So no.
Okay, there's a cubic. Just a sample. I don't know if it's not the right one, but is it a function? Yes. Okay, now the inverse. Ah, but let me trick you now.
Oh,
No.
So it is a function.
no.
Is it not now yet, is it?
If you keep looking, it's gonna be.
Why does it look like DNA?
Is it a function?
DNA.
Yes.
It is. The inverse is. Yes. Because, okay, so the question is, well, let's see on that one. So cubics are a little harder. The question is, can you find an x value that has two y values attached to it that are the same for a function? On this one here. Anybody? Can anybody find an x value that outputs two different y values? That would violate function, right? 21. Care to reason through that for us? Or are you just making statements you can't back up again?
Again?
Okay, we don't know. Okay, so let's just write it.
Wait, so we wouldn't write it?
So it's not a function?
Maybe.
I thought it was a function and then we decided it wasn't.
Okay, this graph is not the graph of what we just did.
Oh.
Okay? So you have to be careful. Remember a function. What do you have to find for a function?
Make sure that it passes the vertical
So
line.
every x value has only one y value, right? Is there an x? That gives two y values. That's your question. We're going to leave it at that because the bell's going to ring. I'm going to give you the work. You can start on it because we didn't get to everything that I wanted to do. Start the review questions and anything you can do algebraically. What numbers does that say?
15, 21, 23.
Yeah, I know.
No, take it.
25, 26, 29, 30, 48, 50, 53, 56.
Oh, we get it on the board.
Now it's on the board too.
That's what we did yesterday. That's what we did yesterday.
We started today.
What's that last number?
So 56. Work on the review tonight if you need to. It's not going to be due tomorrow.
I just said, but the coach played last night. No,